Hi, so welcome to lesson 5. We're going to start looking at enthalpy of combustion. So this is going to be our very first calculation that we do. Now, before we get into what we mean by enthalpy of combustion, before we start, I need to give you a note on how to cross multiply. Okay, so we're going to look at cross multiplication. Now, most of you should already know how to do this, but I'm going to give you a wee recap. Okay, so let's say we burn 1 gram of a substance and that releases, helps if I can spell, that releases 5 kilojoules of energy. Okay, so what we do 1 gram gives us, do an arrow, gives us 5 kilojoules. Now let's say I'm going to make this simple. Let's say we wanted to find out how much 10 grams gives us. Okay, so we do 10 grams, and the important thing is that we keep the units on the same side of each other. So we've got 1 gram here, so grams must be on the left hand side as well. Okay, so 1 gram gives us 5 kilojoules, 10 grams would give us X. Okay, so we don't know what X is. Now you could probably do this in your head. I'm just making it easy just to break it down. Now, what we do is we draw an X. Okay, so from the number up to there, from the 1 down to the X. Okay, so that's what we mean by cross multiply. Now, there's a wee rule here. Okay, the two numbers that are connected together are multiplied. Okay, so the two numbers that are connected are multiplied. Okay, so 10 is connected to 5, so that would be 10 times 5. Now the next one, okay, the number connected to the X, we divide by. Okay, so what we mean by that is in order to get X, we do our two sort of rules. So our first one, the two numbers that are connected together are multiplied, so we do 10 times 5, and the number connected to the X, in this case it's the 1, we divide by. So 10 times 5 divided by 1 equals 50 kilojoules. Now, you could easily have done that in your head. 1 gram gives us 5 kilograms, 10 grams, times it by 10 gives us 50 kilograms. However, we use cross multiplication when we can't do the numbers in our head. So, for example, let's just say, if we call that example 1, example 2, let's just say 11.2 grams gives us, say, 23.9 kilojoules, and we wanted to find out how much 15 grams gave us. Now, there's no way we can do that in our head, so what do? We cross multiply. So make sure the arrows are obviously underneath each other. The units match up, so on the left hand side we've got the grams, on the right hand side we've got the kilojoules. Now it doesn't just have to be grams and kilojoules, it could be anything. I'm only using grams and kilojoules because that's what we're going to use in enthalpy of combustion. So let's draw our X like that. Okay, and let's follow our rules. So X equals, the two numbers that are connected are multiplied. So what are the two numbers? 15, 23.9. So we do 15 multiplied by 23.9, and the number connected to the X we divide by. So what number is connected to the X? 11.2. So we do 15 times 23.9 divided by 11.2. And if I just put this into my calculator, so 15 times 23.9 divided by 11.2. So that is 32 kilojoules when you round. Yeah, and that's it. Okay. Now let's do a third one. Okay, let's say let's go for let's say we burn 5 grams, and that gives us 13.3 kilojoules of energy. However, instead of working out how much energy we need, let's say we want to work out how much mass we need. Okay, so 5 grams gives us 11.3 kilojoules. We want to find out how many grams 20.2 kilojoules would give us. Okay, so we don't know how much to burn. We want to try and work that out. Now, exactly the same idea. We cross multiply, just like so. And follow our rules. So our first rule, the two numbers that are connected are multiplied. Now, it's changed. It's no longer here and here. It's the 5 times the 20.2. So we do that. So 5 times 20.2 divided by, and the next one, the number connected to the X we divide by, so X is connected to 13.3, so we divide by 13.3. And again, if I do that on my calculator, so 5 times 20.2 divided by 13.3, that is 7.59. I'll take it even further, 594. Now, what's important? What side is the X on? It's on the left hand side. What are the units of the left hand side? Grams. Okay, so quite a lot of people make that mistake when the X starts changing to the left side. They put that unit, make sure whatever side the X is at, that's the unit that you use. Okay, so it's 7.594 grams would give us 20.2 kilojoules. Okay, so cross multiplication, very straightforward, very easy, something that we should all have saw at least once in our time. But anyway, we're going to start getting on to the good stuff, which is enthalpy of combustion. Now, what we need to know about that is our definition. Okay, very much like covalent radius, first ionization energy, we need to know that definition. So enthalpy of combustion is the energy released when, and this is very important, when 1 mole, I'm going to come back to that, okay, when 1 mole of a substance burns in excess oxygen. Okay, and it has to be said like that. So enthalpy of combustion is the amount of energy that's released when 1 mole of a substance burns in excess oxygen. So there's a few key words here. Okay, you need to say the 1 mole part. And what makes this confusing is that a lot of people get this mixed up with first ionization energy, because remember, first ionization energy is the amount of energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. This here is the energy released when 1 mole of a substance burns in excess oxygen. So it can be quite easy to mix the two up. You need to make sure that that doesn't happen though. Okay, so energy released when 1 mole of a substance burns in excess oxygen. Okay, so because we've got an excess, a surplus of oxygen, that means we're undergoing complete combustion. Yeah. Now, I want to really emphasize this 1 mole part. Okay, what we mean by 1 mole is we mean the GFM. Okay, so GFM equals 1 mole. Now, I'm just going to very quickly, I'm not going over this, you guys need to know how to do this. So let's say we've got carbon dioxide. If we want to calculate the GFM, we use our data booklet, and for the higher data booklet it's on page 5. Okay, so carbon is got a relative atomic mass of 12 and oxygen has a relative atomic mass of 16. Okay, so you use this quite a lot in National 5 when you're doing your calculations. We bring it back in at higher. So oxygen was 16. So again, like how I always like to do it, I like to draw the lines like that. Okay, start on the right and then work your way from the right to the left. So oxygen was 16, but we've got 2 of them, so that makes that 32. Carbon was 12, and then we add them together, 32 add 12, that is 44 grams. So 44 grams is 1 mole of carbon dioxide. Okay, so when we're talking about 1 mole, we're referring to the GFM. Bear that in mind. Yeah. Now, the best way to do this calculation is just to jump in. So I'm going to take you through a couple, then I'm going to let you do some questions on your own. Try and get familiar with it. So what you might want to do, because I've already got the questions written out here, is you might want to pause the video and then write out the question, and then we'll go through it together. So I'm just going to jump straight in and talk about how to do it. So 1.4 grams of methanol, which is CH3OH, you should know that, was burned. Yeah, the energy that was released was enough to heat 200 centimetre cubed of water by 38 degrees Celsius. Calculate the enthalpy of combustion. Now remember what our definition is for enthalpy of combustion. It's the amount of energy released when we burn 1 mole of a substance in excess oxygen. Okay, so just keep that in the back of your head. Now what we do in chemistry, we like to split our page. You guys are used to it getting split into 3. For enthalpy of combustion calculations, we split it into 2. Okay, now there's 2 headings I want you to put every single time you do one of these calculations. It's going to be EH equals CM delta T. We've seen that equation before, yeah, we did it in National 5. And on the right hand side, I want you to write EOC, and then what that stands for enthalpy of combustion. Okay, now in brackets, remember enthalpy of combustion is 1 mole. And what do we mean by 1 mole? The GFM of a substance. Okay, so these 2 headings are so important. Just remember that 1 mole is the same as the GFM. Yeah, a lot of people get that confused. Now, let's look at this question here. The energy release was enough to heat 200 centimetre cubed of water by 38 degrees Celsius. Now, if we put our sidebar down like that, yeah. Now, it's water we're talking about. So this specific heat capacity is 4.18. You should know that off the top of your head. M, what is M? Is it the mass of the substance or is it the mass of water? You should know from National 5 it's the mass of water. So 200 centimetre cubed. Now remember, we need to convert that into kilograms. So 200 centimetre cubed is 0.2 kilograms. Yeah? And it was enough to heat the water by 38 degrees Celsius. So the change in temperature, it's went up by 38 degrees Celsius. So we're trying to work out what EH is. Yeah. Now, if you're always given this information about the mass of water, about the temperature, you should always work out EH first. Now, let's put this in. So EH equals 4.18 times 0.2 times 38. Now, if we do this in our calculator, so do it with me, yeah, make sure I don't make any mistakes because it's easy done. Deliberate, mind you. So 4.18 times 0.2 times 38, I'm getting an answer of 31.768, and the units are kilojoules. Okay? So, in National 5, usually you would get 3 marks for that. And higher, you only get 1 mark. Okay, so we're stepping it up. Yeah? Now, I want to make a wee note. Is that the EH value is the only number that can cross over the line. Okay, so there's a reason that we split this page here. This is a very special line here. The only number, the only value, sorry, that can cross over this line is the EH value. So 31.768 we can bring over to this side. We can't bring over C, we can't bring over the mass, we can't bring over the temperature. It's only EH that can cross over here. Okay, now, before we start worrying about that, we're trying to work out the enthalpy of combustion. Remember our definition. It's the energy released when 1 mole of a substance is burned in excess oxygen. So what we need to do is we need to calculate what 1 mole is. Okay, so the question is asking about methanol. So we need to calculate the mass of 1 mole of methanol. And how do we do that? Well, it's just a National 5 calculation. So start on the right, hydrogen. We've also got another hydrogen here. So in total, that's 4. Oxygen is 16. And carbon is 12. If we add all them up, what do we get? We get 32 grams. So 32 grams equals 1 mole. Yeah, and that there, if you calculate that, you get a 2nd mark. Okay, so 1 mark for doing a National 5 calculation, another mark for doing another National 5 calculation. Okay, now there is a 3rd mark, and this is where this comes into it. So what we can do is, how much methanol have we burned? We've burned 1.4 grams. Okay, I'll highlight that. So in National 5, you would never use this number. They always put this number in to try and trick you. However, in higher, we need to use this number. Okay, so when we burned 1.4 grams of methanol, how much energy did we get? Well, there it is. Yeah, so what we can do, we can bring that number over. So 1.4 grams, yeah, 1.4 grams of methanol burned to release 31.768 kilojoules. Okay? Now, if we draw another arrow, yeah, we don't want to find out how much 1.4 grams gives us. We want to find out how much 1 mole gives us, because remember, our definition of enthalpy of combustion is the energy released when 1 mole of a substance is burned in excess oxygen. So we've already calculated that 1 mole is 32 grams. So if 1.4 grams gives us 31.768 kilojoules, then 32 grams gives us X. Yeah, we don't know what the enthalpy of combustion is. And that X, that is our enthalpy of combustion. Okay, now, what do? We cross multiply and we go back to our rules. So our first rule was that the numbers that are connected, you multiply. So that would be 32 multiplied by 31.768. Okay, and then our second rule is that the number connected to X, you divide by. So 1.4 is connected to X, yeah, so we divide by 1.4. And if I do this, do the calculation with me, just make sure obviously it is correct. So 32 times 31.768, yeah, hit equals. So once you put that in your calculator, 32 times 31.768, hit equals, then divide by 1.4. And what are we getting? We are getting 726. Okay, so that there is our answer, 726. Now there's a couple of things that you need to be aware of. When it's enthalpy of combustion, you need to put a negative in. Okay, negative 726, because what that means, that negative, we'll learn about this when we do rates of reaction and stuff like that, but that negative means it's an exothermic reaction, yeah? And remember, anything we burn, a combustion reaction, is an exothermic reaction, so we need to have that negative in there, because if we don't put that negative in, the marker, whoever that may be, will think you're talking about an endothermic reaction and you'll lose a mark. I know that sounds brutal, but that's what we're dealing with in here. So make sure you have that negative, and I can't actually stress that enough. I'm going to highlight it. Yeah, make sure you get that negative in there. And usually the units will be in the question, but obviously it's kilojoules. Yeah, but because it's the enthalpy of combustion, because it's 1 mole, it would be kilojoules per mole. Okay, and if you get all that right, so if you get the right number, the right units, and the negative, you get your third mark. Okay, these questions are usually worth 3 marks. And that's it. It looks complicated. Yeah, it does. But when we go through it slowly, there's not a lot to it. Okay, there's not a lot. Right, going to go over the next question. So again, it's enthalpy of combustion. So what do? Split our page into 2. Okay. Then we put our 2 headings. So we put our EH equals Cm delta T, and we put our EOC. What does that stand for? Enthalpy of combustion. In brackets, what does that mean? It's the energy released when 1 mole of a substance is burned in excess oxygen. And what does 1 mole equal? It equals the GFM. Okay, make sure you get that connection into your head. Right, so 4.2 grams of ammonia, which is NH3, yeah, we make that in the Haber process, is burned. It releases enough energy to raise the temperature of water, 500 mils of it, from 20 degrees to 26 degrees Celsius. Okay, so let's do a wee sidebar down here. We know our C, but always know our C if it's water. The mass is 500 mils, but remember we're trying to get it into kilograms, and then because it's water, kilograms equals litres, so we want to divide by 1,000. So that is 0.5 kilograms. Yeah, 500 mils is the same as 500 centimetre cubed. And delta T is the change in temperature, so it went from 20 degrees Celsius to 26. So the change in temperature is 6 degrees Celsius. And if we put those values in, so 4.18 times 0.5 times 6, we should get, again, do it with me, so 4.18 times 0.5 times 6, what we getting? I've got 12.54 kilojoules. Okay. Now remember, that value there, because it's EH, that's the only value that can cross over. Okay, so just be aware of that. Now, so that's our 1 mark for that. 3 marks at Nat 5, 1 mark at higher. Enthalpy of combustion, we're trying to work out 1 mole. How do we work out the mass of 1 mole? It's the GFM. Okay, so ammonia, which is NH3, hydrogen is 3, nitrogen's 14. Yeah, if we just take this again, nitrogen, yep, there it is, 14. Okay, so that adds up to 17 grams. So again, that's our connection there. 1 mole is 17 grams. Right, so how much ammonia did we have? Well, it's there in the question. .2 grams. Okay, so 4.2 grams. How much energy did that give us? Well, what number have we crossed over? Here it is. So if we burn 4.2 grams, and that releases enough energy to do that. So 4.2 grams burns to release 12.54 kilojoules. Yeah, but that's not what we're after. Yeah, we're after the enthalpy of combustion. What is the enthalpy of combustion? It's the energy released when 1 mole of a substance is burned in excess oxygen. So 1 mole is 17 grams. So 4.2 grams gives us 12.54 kilojoules. 17 grams gives us, do we know what it gives us? No, we don't. So it's X. So we cross multiply, just like that. Yeah. So X equals, remember our rules, the two numbers that are connected together are multiplied. So 17 and 12.54 are connected. So we multiply those two together. And we divide by the number that's connected to X. So X is connected to 4.2. And if we do this in our calculator, so 12.54 times 17, remember to hit equals here, yeah, and then divide by 4.2, and what do we get? We get 50.76 if you round up correctly. Now, are we finished? Hopefully you're saying no. Hopefully you're like, oh, Mr. McClay, you are an idiot. You've forgotten to put something very important. What have I forgotten? The negative. Okay, and what does that negative tells us? It tells us it's exothermic. Yeah. And obviously our units, because it's on that side, it's kilojoules, of course, but we've calculated the enthalpy of combustion, which is the energy released when 1 mole of a substance is burned in excess oxygen, so it's kilojoules per mole, and that is our answer. Okay, so 1 mark there, 1 mark for calculating your GFM, and then your third mark, if you get the right number, negative and the unit, and that is enthalpy of combustion. Okay, so what I'm going to do, I'm going to put up some questions for you guys on Teams. Next week, what we're going to do is we're going to do similar questions, but this time, instead of having to try and work out the enthalpy of combustion, the question will give us the enthalpy of combustion. We need to try and work out the mass. Yeah, so we're doing it backwards. Now, it's important that we're able to get this bit done first. If we can do this stage of the calculation, the next part will be easy. Okay, so make sure you understand this. You can rewind the video, watch it. If you've got any questions, email me. Come on to Teams during the lesson, and we'll get that sorted. Okay, so I'll put up some questions for you in Teams to do, and let me know how you get on. Right, thank you.